I know a lot of you are struggling with 3-7. I'm going to give you a hint and then I'll try to give you more hints later. But just to begin, so we have 3 isosceles triangles. And these sides are the same. So we'll call this X. So all those sides, here I'll highlight them. So this side, this side, this side, and this side are all equal. Now we have 2 things. One's called the law of sines. And the law of sines says that the sine of A over A is equal to the sine of B over B, which is equal to the sine of C over C. Perfect. Let me explain the law of sines. I'm going to put up a video soon, but I haven't finished editing it. That's why it's not up. Let me just give you a brief summary. So I have a triangle. It's not a right triangle, so we can't use our normal trigonometry. It doesn't really matter what I call A, B, and C, but the side across from each of, like the side across from A is A. The side across from B is B. The side across from C is C. That's what all these letters are. Now, for this problem, I know that this won't work because we'll have one equation and 2 unknowns. So we have to use the law of cosines. The law of cosines basically looks almost like the Pythagorean theorem, except we don't have a hypotenuse. So we can just say a squared equals b squared plus c squared, and it doesn't really matter what order those are in because I don't have a hypotenuse. But this does matter. I'm going to subtract 2 times the variables on the same side. So 2 times b times c, and then times the cosine of the angle that corresponds to A. So it would be cosine of A, capital A. And why I say it doesn't matter, I can also say B squared equals A squared plus C squared minus, and then 2, and then the 2 variables that are on the same side are A and C, and this would be the cosine of capital B because it corresponds to what I'm trying to find, the side B. And again, I can say C squared equals A squared plus B squared minus 2AB cosine of C. Okay? I'm going to turn off the recording.